Hello and welcome to this first radio style video. This is just going to be audio. I might have some images playing throughout the recording, but primarily the focus of this is just what I have to say. So I wanted to make this video, or rather recording, to talk about something that's definitely been of interest to a lot of people over the past few months, maybe even year, and that is crypto, right? Cryptocurrency, things like Bitcoin, ethereum, and what it all means, because I think so much of the current talk around Bitcoin and around cryptocurrency and ethereum and some of these platforms, it's a lot of speculation. It's a lot of, for lack of a better term, hype surrounding something that's poorly understood, and not only that, but what I really get a sense of is that there are people that really are basing their valuation of this thing on potential without being very clear on what that potential is. So the idea that, okay, crypto is this thing that maybe is not being used right now and is maybe not as useful right now, but will have the potential to be very useful. But they never really answer the question, well, what is that potential? What is it going to be used for if it isn't used for anything particularly interesting now? So I wanted to talk about a few different things, and the first thing that I wanted to talk about is this kind of, I guess, this mistake that people make in lumping them all together, right? We have this word cryptocurrency, we have, crypto platforms and this kind of thing, but we lump these things together without really asking ourselves why. And the honest answer is that there isn't a good reason to lump them together. Something like Bitcoin is not comparable to Ethereum, right? It doesn't make any sense to say, oh, well, Bitcoin, it looks like Bitcoin adoption is up, so now we can expect that Ethereum should do better. These things don't really have anything to do with each other. Ethereum is itself not even a currency. It is a platform. Now, it is true that there is a currency that, the most sort of widely used currency on the Ethereum platform is Ether, and there are relationships between the currency on the platform and the platform itself. But we'll get into that. So I just wanted to start this with, again, the basic premise that these things are not necessarily related. They're not all one thing. They don't all, take value from each other. So the fact that Bitcoin is gaining adoption doesn't mean that, Ripple is going to be more, have more significance in the market. Now, it is worth recognizing, and we're not going to spend too much time on this, but there's kind of the sort of valuation methodology that says, okay, we should value these things based on some sort of inherent value. And then there is also the one that values things based on, well, what will the value practically be? Like, what will other people value the thing? Because in the end, that's all that really matters. We're not going to talk so much about that because that gets into a lot of sort of group psychology, and it's not really interesting to actually talk about the technologies in that mindset, because there's a lot, talk about the tulip fever, whether or not it's historically accurate, the kind of the craze surrounding the Dutch tulips, that I think we can all argue there was no inherent value in that commodity, but that kind of group psychology allowed something sort of that economically didn't make a lot of sense to happen. So we're just gonna limit our focus to the technology itself, and what kind of impact it can have, what kind of impact the technology can have, not what kind of speculation can we expect to happen in the next few months. There's no shortage of that. If you're interested in that kind of analysis, that's not what you're going to find here, but there are many other sources you can find that from. So we're just going to start with that. What is the technology? We're going to start with Bitcoin. What is Bitcoin from a practical standpoint? What can be done with Bitcoin? We're not going to get into how Bitcoin works. Again, there are many videos detailing, even at a very, very low level, exactly how Bitcoin functions. What we want to talk about is kind of what are its impacts, what are its implications, what is it used for now, what could it be used for in the future, and what are its limitations. So, why might there be alternatives to Bitcoin? Why is there not just Bitcoin? We obviously don't have alternatives to cash. There's not cash A and cash B, so it seems a little bit weird that there would be, however many different cryptocurrencies that, all purport to do, at least at face value, what Bitcoin does. So Bitcoin is a cryptocurrency, right? We've already said that, but what does that mean? It means that it is a sort of cryptographically secured statement of value. Basically, when you've got cash, there's a kind of a physical assurance, right? There's something in your hand that you're holding, and the universe ensures that what you're holding in your hand doesn't disappear or fly away or suddenly fly into someone else's hand. It can be stolen. There are things that can happen to it, but in a basic sense, if I put something under my cushion, in my mattress, it'll stay there. Now, in the digital space, things are a lot more complicated. There are many more threat vectors than there are on physical cash. Yes, it's true, you can steal it. Yes, it's true, you can do all kinds of complicated things with it. You can try and, forge it, this kind of thing. But in the digital space, these threats are multiplied. Because, of course, when you talk about something that's moved and communicated across the internet, someone has to be in your house to steal your cash. Someone doesn't have to be in your house to take advantage of something that's stored across a network or that kind of thing, to steal that. So the basic, the idea of cryptocurrency comes from this cryptographic securing of the currency, right? This idea of actually deciding who owns it, and if you own it, what does that mean? So at a high level, what Bitcoin sort of establishes is essentially a payment network, a way in which I can make payments. And the way in which you make payments is by moving around, well, not exactly moving around, but basically by using the currency Bitcoin. So what you can do is essentially have a certain amount of Bitcoin and then use the Bitcoin payment network to pay for, supposedly, for services in the real world, right? So you've got this kind of digital space that is this, what's called a public ledger that manages Bitcoin, manages where it's stored, where it gets sent to, where it gets sent from, all this kind of thing. At a very high level, it's just a payment network. And then in the real world, you have the actual exchange of goods. So maybe you're buying a house or renting an apartment. And these are things that aren't really done with Bitcoin right now, but they could be in the future. So what makes that payment network better than the payment networks that we have in the real world? Why should I use Bitcoin? And that's the kind of the practical aspect of this. Bitcoin is a great payment network for a few reasons. It's also a bad payment network for a few others. The first reason is that it's a great payment network is that it uses this cryptography to essentially move money in a kind of an agnostic way, in a way that doesn't really assume anything about the money. You don't have to have all these complicated sort of payment processors and payment networks that all have to communicate with each other in complicated ways. You just have, in a sense, a very simple sort of ledger and a way to agree on the way in which that ledger works. And this allows you to essentially beat the banks, to move money very, very efficiently. You can talk about moving, hundreds of thousands, millions of dollars, billions of dollars in a matter of, half an hour. And with a cost of, I don't know, maybe $5, $10 to move that money. That is unheard of. If you can imagine trying to do something like that with Visa, it doesn't even make sense. It doesn't mean anything. Moving that kind of money is very expensive. It's very sort of, there's a lot of risk there. You're talking about sort of direct transfers between banks, and when you talk about sort of, international banks and how they communicate, the different protocols and this kind of thing, it's a real undertaking. That Bitcoin can do that as effectively as it does is real sort of impressive part of that network. But at the same time, as powerful it is when you talk about these kind of big transfers, it's also quite weak when you talk about the small stuff. Because of the way that it's architected, Bitcoin kind of always assumes it's under attack. It always assumes that the worst could happen. And that means that very small transactions that would take half a second with a Visa card, like buying a muffin, for $5 at the grocery store, those transactions become quite costly, because that same $5 that you would have to pay and the same 30 minutes that you would have to wait at at the scale of a million or $1 billion, or smaller than that $100,000 transaction, that's the same here when we talk about the muffin. Now, when we talk about the 30 minutes, what we're really talking about is kind of how sure are we that the transaction was valid. And it's true, even when you talk about like a Visa transaction, there's not all that much security that goes into that actual transaction. If you really wanted to know that that muffin was correctly purchased with a valid card, that the payment will not be reverted, you might have to wait longer. And there's just that kind of basic presumption, I guess, of the innocence of the transaction that says that the Safeway supermarket does not wait for the Visa to kind of confirm the transaction to the full extent of its power. In the same way, a supermarket doesn't necessarily have to wait for 30 minutes actually comes from 3 confirmations, which is a generally agreed upon kind of level where you're almost absolutely certain that this is a valid transaction. You could wait for 1 confirmation, which would just be 10 minutes. Or you could wait for no confirmations. You could just say, you know what, it's good enough that the transaction is out there. Just kind of take them on their honor. So there's that kind of thing. But I think 10 minutes is a good kind of minimum to say, okay, it has to at least be confirmed once. And that's a long time, right? That seems like an unreasonable amount of time to be spending on this, what's essentially kind of a trivial transaction. And not only that, you're paying those $5, right, which is the price of the thing you're trying to buy. That's a lot. And this is where we really get into kind of the limitations of the Bitcoin network, right? Because of the way that it's structured, transactions are, expensive to confirm, right? It takes a lot of power on the part of miners, and these miners are the ones that are essentially going out and trying to confirm transactions. Because there are so many transactions in the network, and that's not just in the future, that's right now, the network is in a sense very overloaded, and so the price the sort of incentive, the economic incentive that you have to sort of give to the network to encourage miners to try and get your transaction instead of your friend's transaction, when you have so many transactions running through this ledger, through this network, those incentives have to get bigger and bigger. So maybe it's not even $5, it's $10, $15, right? And the faster you want to be confirmed, if you want to make sure that it actually happens in 10 minutes and not half an hour or an hour, that number can jump up pretty quickly. Which again, at the scale of hundreds of thousands of dollars, even just $1,000 doesn't seem that significant, right? Who cares that you're spending $10 on this transaction? Well, maybe $1,000 is not enough, but at the lower level, right, at those kind of more routine transactions, this is what you're doing most of the time with cash. You're not dropping $1,000 at the grocery store. You're paying $5, $10, $50 maybe, and so at that level, the transaction network seems to be slow, seems to be expensive. And at a basic level, this has to do with the limitations of the technology. The security that it affords you, in a sense, is absolute. But getting absolute security, it's kind of an all or nothing sort of thing with Bitcoin. It's either totally secure or not secure at all. And getting total security is expensive, and it will only get more expensive as more people use the network. Scaling Bitcoin is a very controversial issue, and it's basically where most of the what are called altcoins, so the kind of alternative cryptocurrencies to Bitcoin, it's where most of them come in. They provide sort of alternatives to Bitcoin, either pretty direct alternatives, that simply try and allow for faster processing of transactions, or kind of more indirect alternatives that provide different mechanisms for actually processing the transaction, so different sort of payment networks as opposed to just scaled versions of Bitcoin. And it's a real question. Scaling crypto is not something that it's just around the corner or we already have it. It's just people haven't recognized it yet. Trying to get something to work in a way that is both resilient but also efficient, it's an open problem, and it's one that as much as these sort of cryptocurrencies get hyped up and people are sort of shouting, "Oh, this is the one, this is the one, this is the one that's going to solve all our problems." It's still very much a kind of an open question. So I'm going to take a break here talking about Bitcoin and talk about Ethereum. So Ethereum gets lumped in with Bitcoin, and there's actually no reason for that. Ethereum is not Bitcoin. It is not a cryptocurrency. It is a platform, what is called a blockchain platform. And blockchain technology is, of course, what underpins Bitcoin and its public ledger, but it's also what underpins Ethereum. So Ethereum has been called the world computer, and basically what it is a sort of public ledger of computation, which sounds crazy. It's a very abstract idea, and I don't expect you to sort of immediately understand this, but it is a kind of an interesting thing to think about. So what Ethereum essentially allows you to do is build applications, contracts specifically, that are run in a distributed manner so that the result of the computations is agreed upon by everyone. So the most, simplest example is a currency, right? Some contract that would allow you to sort of send and receive money, value, let's say, just to keep it abstract, and to have an entire network agree upon, the result of that computation, how much money you have, how much money you sent. And there you basically have Bitcoin, right? You basically have a cryptocurrency. And there is a cryptocurrency built on the Ethereum platform. It's called Ether. It sort of underpins the economic incentives of the Ethereum platform. And that's the next interesting thing about the Ethereum platform, is that if you consider this world computer idea of computations being run on everyone's computer, because that's the only way to ensure that those computations are correct, that you don't have just one bad actor, or one, by bad actor we mean sort of bad agent, someone who's trying to do harm. You could just have them say, oh, the result of this computation is X. And if people aren't actively sort of testing that assertion, who's to say that it is or isn't? And this might seem abstract, but when we say that the result of the computation is X, that could mean that, oh, I now have $15 million. Well, that's probably something we want to test. So testing seems like the reasonable thing to do, right? But the trouble with testing is that it costs time, it costs computation. If everyone could assert whatever ridiculousness they wanted to assert, then it would essentially run the network to the ground. Everyone is asserting some random thing, and everyone else, for every one of those assertions, is having to compute the thing that they computed, supposedly, and test the value. And this is ridiculous. This could never work. So what the Ethereum platform does is it builds into its platform economic incentives that allow you to say, basically, okay, I'm asserting this, but there's a certain cost to this assertion. And so this sort of balances the incentives in such a way that, yes, you're asserting this, but also show me some money, show me some cost to this assertion to tell me that you're not just doing it for a joke, right? So it's these two ideas, this idea of the sort of the global computer where everyone's computing the same things, and those computations are stored in what are called smart contracts, and these are, again, these are computations to be run on that global machine, to be run by everyone. And then there's those economic costs, those economic disincentives, we call them, to discourage the use of this, discourage spam on this machine, basically. Just sort of declaring computations without, actually wanting to do anything with those computations, expecting those computations to be rejected or whatever, or maybe used, but not used for much of anything. There should be a cost associated with that, because obviously if this computation is worthwhile, then you will accept that cost, and if it isn't worthwhile, then you won't accept this cost. And so it's a very simple way of just discouraging spam. Imagine if for every email you had to pay 1 cent. Now I know for people that send a lot of email, this might it might rack up, but for most people, this is probably a reasonable cost to pay, right? 1 cent. How many emails do you send in a day? 10 emails, let's say. That's 10 cents a day. So it adds up, yes, but it doesn't represent a significant cost to the actual operation. But if you consider someone who's sending a lot of spam, if you want to actually have effective spamming, you're going to need to be sending, millions of emails a day. Well, that becomes incredibly expensive, and so effectively it neutralizes spam. One other way to think about Bitcoin is that the economic incentive here, or rather disincentive, is the computation time that it actually requires to spoof the network. And this has actually been used outside of the crypto space in email again, so it's a great analogy. Another way to think about kind of controlling spam is, instead of paying 1 cent, you pay a certain amount of computation time. So let's say to send 1 email, it takes you 10 seconds to send it. And yes, I know for people who send a lot of email, this might seem like, oh my god, 10 seconds, I need to know that it's instant. But for most people, this is going to be a reasonable amount of time to spend waiting to send your email. But if you're a spammer, and again you're sending millions of emails a day, well, you won't be sending millions anymore, because it takes you those 10 seconds always to send the email. So there's a computational cost associated with it, and that essentially forbids you to send anything close to 1 million emails, much less than that, and again effectively neutralizes spam. So these two sort of platforms, the blockchain that's used in Bitcoin to create this sort of cryptocurrency, this payment network, the blockchain used in Ethereum to create these smart contracts, they have different uses. Basically it makes sense to think about Bitcoin as just a payment network. There are people who will argue and say that Bitcoin is a store of value, like gold, and this is not unreasonable. It is, the network that agrees upon payments is the same network that agrees upon where things are, right? Those are one and the same, and so in that sense Bitcoin is a store of value. But I sort of object to this idea of to anything as being a store of value. I think it's a little bit absurd. These are the same sort of people who think that holding on to cash is somehow like a flawed idea, and sure, there are things that can affect it, and there are extreme examples of hyperinflation, this kind of thing, where it does matter where your money is, what kind of instrument it's stored in. But at a basic level, it doesn't really matter whether you have your money, stored away in a mattress or stored away in gold. It's all the same. The markets are super liquid. Prices don't change that much, and any of the changes in the prices basically just boil down to speculation. It's not really anything to do with the inherent value of these things. It just has to do with, again, this sort of group psychology. A bunch of people think that, the government is going to steal all of our cash, and so now we have to put all our money in gold, honestly. So I don't think this is really a reasonable thing to say that Bitcoin is some special store of value. Yes, there are cryptographic sort of securities in place that make it more secure than cash. You can't steal Bitcoin in the same way you can steal cash. But for 99% of the population, it doesn't make any sense. 99.99. Let's even go farther. It doesn't make any sense to talk about cash as being this kind of I think people think about cash as this thing that's just going to fly away. It really doesn't, right? If you've got it in a bank account, you're basically fine. So, yes, it can be used as a store of value, but I don't think it's any more effective than cash. Alright, so that concludes this kind of basic introduction to a couple of the most prominent cryptocurrencies, Ether and Bitcoin, where Ether comes from, the Ethereum network, where Bitcoin comes from, what a cryptocurrency looks like, the kind of the blockchain model, and an analysis of these things as payment networks. We didn't really get into what the applications of Ethereum are, and maybe I'll look at that in a future video, but basically the gist of this is you need to stop thinking about these things as just value. right? That so many people like to point at something and say, this thing has value because it's X thing. And from an economic perspective, that doesn't make any sense. You know, to say that a computer is worth $1,000 because it's a computer, that's a circular argument. To say that Bitcoin is worth $1,000 because it's Bitcoin, well, what does that mean? It's Bitcoin, you know? And people point to things like scarcity, but that's also not a reasonable, you know, argument, because just because something is scarce, you know, if I don't know, blow my nose on a tissue, that's the only tissue with that specific pattern of mucus on it, that is a very scarce thing. One of the, you know, the most scarce thing, in the sense that nothing can be more scarce than just having a single version of it. Does that make it valuable? No. So, you know, these kind of typical, I guess, discussions of cryptocurrency and blockchain technology, you know, a lot of these sort of circular arguments where people just sort of assert things. They don't talk about what the thing actually does, what kind of effect it has. They just talk about the thing, you know, and they just keep saying the name, like that means something. So I wanted in this video to just kind of break away from that mold a little bit and talk about what these things are used for. What are the practical uses? If I want to use Bitcoin, how would I use it? What is it used for? You know, where does it perform well? Where does it perform badly? How would I use the Ethereum, you know, blockchain platform? Now, we didn't really get into that as much, but I gave you the basic idea. A world computer where you can sort of secure computations, this kind of thing. Some of the most basic kind of applications are things like voting. So you could have a contract that allows you to vote. The votes then are secured by the blockchain. So we don't allow things like double voting, or we don't allow people to spam votes or to steal other people's votes or this kind of thing. So it's this idea of a world computer, right? Alright, that about sums up basically what I covered in this video. Hopefully this wasn't too long, and hopefully it was pretty easy to understand. I didn't try to delve too deep into any of these ideas, just stayed at a high level of abstraction, tried to, you know, keep things simple and to the point. So hopefully you enjoyed this, and thank you for watching, or rather listening.